Hey everyone, it's Drew again from GPI, and today we're going to be talking about chemistry. But to talk about chemistry, we're going to make it fun by making some ice cream to explain endothermic and exothermic reactions as well as freezing point depression. Alright, so to do this little experiment, you're going to need some half and half, some ice cream salt. Regular table salt works fine. Vanilla, sugar, measuring devices, and a big Ziploc bag and a smaller Ziploc bag. Alright, so before we get into the chemistry of it, we're going to just start by mixing together our ice cream ingredients. First thing we're going to do is add a cup of half and half. There's a lot of different recipes online for different ways of making ice cream. You can even make ice cream without using lactose. So if anyone's lactose intolerant, there's plenty of recipes for lactose-free ice cream. So yeah, now that we got our cup of half and half, we're gonna add 3 tablespoons of sugar for the recipe that I've decided to use. 1, 2, and 3. And then the last thing we're gonna add to this mixture is a teaspoon of vanilla. Alright, now that all those things are in the bag, I'm gonna zip it up, give it a little shake to mix it around, and then put it in the fridge so it cools a little bit more. And that is gonna help with the freezing process for making ice cream. While the ice cream is chilling in the fridge, I'm gonna talk about chemical reactions. Well, a chemical reaction is the interaction between 2 or more molecules that cause a change, a molecular change to be specific. This change can either result in an absorption or release of energy. And this energy can be many different types, whether it's heat or sound or light. It's all forms of energy. And either the absorption or release is either an endothermic or an exothermic reaction. An exothermic reaction is a reaction that releases heat. An example of this would be a fire. A fire is a great example of an exothermic reaction because everyone knows that a fire is quite hot, and that's just you feeling energy in the form of heat being released from the system. On the opposite end is an endothermic reaction, and that is when energy is absorbed into a system. An example of this is when you have a snowman out in front of your house and the sun's beating down on it. It's absorbing energy from the sun, and that is what causes the snow to melt. So I'm going to explain what a solution is. A solution is a mixture of 2 or more substances. One of the substances is the solute, and in this case it's salt. And the solute is dissolved in the solvent, which is water in this case. And as they dissolve and mix together, it causes chemical property changes to occur. So the chemical property change that happens when you add salt to water is a freezing point depression. What that means is the natural freezing point of water is 32 degrees Fahrenheit or 0 degrees Celsius. And when you add salt to water, it chemically changes the properties and causes the freezing point to be depressed or lowered, depending on how much salt you add. All right, so now we're gonna do a little side experiment to better understand solutions and endothermic reactions. So right here in front of me, I've got a cup of room temperature water, and it's at about 74 degrees. What we're gonna do is we're gonna add some ice cream salt to the mixture. Just gonna add a bunch. And as this dissolves into and turns into a solution, we're gonna see what happens. I'm gonna stir this around a little bit. All right, so now the salt has been in the water for a little bit, and as you can see, the temperature has dropped 4 degrees, and it's now at 70 degrees Fahrenheit. This is a wonderful example of an endothermic reaction because energy was absorbed to dissolve the salt into the water. All right, so now we've got a bunch of ice in a bag, and I've got the thermometer in it, and because the freezer is below freezing, the ice is sitting around 9 degrees Fahrenheit. So now we're gonna add some salt to make the ice even colder, and we're gonna add our ice cream mixture. You just want to dump a good amount of salt and then add the bag in there and ziplock it up real tight. And start shaking it around. What you want to happen is the salt is going to start dissolving on the outermost part of ice because there's a little bit of liquid water for the salt to dissolve in. And this is the same endothermic reaction we just showed in the cup. And it's going to have the same effect on the ice, and it's going to make it even colder. It's important to shake your bag so that the ice cream mixture gets churned and mixed around and comes out with a nice smooth consistency for the ice cream.
Our bag started to leak. Oh no!
All right, so now the ice cream's been in the bag for a little while, and we did a bunch of shaking. We even put it in the freezer to help it out, get a little bit colder. This took, it was probably about a 15-minute process to get it totally where we like it. But now, the ice cream's in pretty good consistency, and it's pretty cool because we were able to do this because of science. So now we got some delicious ice cream. Totally feel free to add toppings if you want, or just eat it how it is. It's pretty good ice cream. If you want to do this at home, make sure to ask your parents' permission first. And it's a pretty simple procedure. And like I said before, if you don't have ice cream salt, normal table salt works fine. And yeah, enjoy your day. I hope everyone enjoyed the video and had fun making ice cream on their own. If you do make some ice cream, you can post about it and tag GPI. This is a great activity to do right now because it's easy to maintain your social distancing while at home. But if you do go out to get ingredients, remember to maintain that social distancing when at the store. And I'm gonna link more information about the chemistry of making ice cream in the description. Have a great day.